Okay, so well, continue the question part L. So integral u to the power 6. Okay, and then finally x squared dx. So remember to check about the step number 2 because you rearrange the result. So that means the du over 12. You put the 12 back to the left hand side. So while dx put it back to the right hand side, we have x squared times dx, which should be du over 12. So this part should be substituted by du over 12. So please be careful, put it back correctly, and then you will have 1 over 12, put it outside the constants, u to the power 6, and then du. So the step 4 is that you integrate the following integral. So you have u to the power of 7 over 7, and then 1 over 12. And then finally the part 5 is that so we will have 1 over 84 because both of them multiply together, and then replace the u by 1 plus 4x cubed to the power of 7. So finally remember to plus constant. So this is somehow one of the demonstrations about using the method by substitution. And then we can go ahead further to the part N. So because this is in fact, but you can try yourself, but actually you can see the explanations for it. The part N I write here. So you have a question, so which is in fact integrals x squared and then e to the power of x cubed and minus 1. First of all, compare the two functions, to which you have x squared and then you have e to the power of x cubed minus 1. And then what you need to do is that, as I said, just like the previous link, is that you have to choose the u to be the highest power. So which in fact the step number 1 is to let u to be x cubed and then minus 1. Okay, so therefore we can get the step number 1, and then the step number 2 is that we have to d the function for one time. So that means that we've got 3x squared. Okay, so step number 3. So step number 3 is that so we need to do some replacement. So the step number 3, the questions can be replaced by u for this part. So we can replace by u, and that x squared times dx. So this part, remember to read about the step number 2. Put the dx on the right hand side, bring the 3 to the left hand side, and therefore you will got x squared times dx will be du divided by 3. Alright, so the number 4, so you have 1 over 3 integrals e to the power of u du. Afterwards, so you will have to integrate this one, which is unchanged, okay, according to the rules that I have just said before. And then the number 5 is that replace the u by x cubed minus 1 and then plus constant, and that's all. So the rest of the question, so you can actually try yourself, and then we have to go to the next and the final methods of the integration, so which you can take a look for your lecture notes, which is the integration by parts. That is in your page, it's a slide 23. Okay, so far the last method is the integration by parts. So what you can do is that you will have some things like the equations of integrations. Integrals u times dv, and then equals to uv minus integrals v times the du. So what does it mean is that we have two functions. Okay, we have two functions, and then we have to choose one of the functions to be u, and the other functions to be chosen as dv. Okay, so choosing u, so choosing dv. Well, let's take a look for using one example. You can turn to the slide number 13. It's a side train 6 should be. Okay, now what you have to do is that you will have the following. There is one example, so which is x times dx maybe. Okay, so we use this one. Integral x times ln x. So we have two functions. So one is x, the other is ln x. So we are trying to choose one of it to be the u, and the other one should be the dv. Well, which one should be u? Okay, as I said, which you need to choose one of them to be u, and the other one is dv. Just take a look. Since in these equations we are going to integrate the v for one time, therefore we are going to choose some functions which is easier to integrate to be the dv. And according to the functions, one of the technique to choose the dv, okay, so we should choose the dv which is easier to be integrate. Okay, so choose the dv which is easier to be integrate. Okay, so let's get started. Comparatively, if we integrate the x, which will be easier to be integrate than the ln x. Okay, so therefore we are going to set u to be ln x. Okay, u is a function which is more difficult to be integrate, and then dv should be something that is easier to be integrate comparatively. So in this case we have to set dv to be x times dx. Okay, and then the next one is that we are going to find the following. Okay, according to this equation we need to have v, we need to have u, and we need to have v and then du. So just write down the following: u dv, uv minus v and du. Okay, and then you are going to do the substitution one by one. So u is ln x, but what is v? V is to integrate this one. So therefore we are going to choose the function which is easier to be integrated, such that we can get v easily. Okay, we can get v easily. So how to get a v? Of course, we can both sides integrate. Okay, both sides take integrate. If you d the function and you do the integration, that means you cancel each other's, and then therefore the answer is just v for the left hand side. So while if you integrate the x, the answer will be x squared divided by 2. Okay, therefore you can actually have, this is u, right? V should be x squared divided by 2. Okay, x squared divided by 2. And the next is minus integrate v. V is the x squared divided by 2. And then du, which means that you have to d the u, which you already set by one time. And in fact, the du equals to 1 over x times dx. Okay, so this is v. And then du, which means 1 over x times dx. Okay, so this is the du. So therefore, after we got u, we got v and then du, we substitute inside the integration by parts, and then we can actually continue. For the first part, we have nothing to do anymore, but just write down this part. And the rest of them is that we have x squared cancel out, which is x over 2. Okay, and then the final part is that you still need to integrate this one, and then the answer is that, well, just copy and paste the first term, and then we need to integrate this one. It should be this part. Okay, so finally, but this 1 over 2 is coming from this one because we take out 1 over 2, and then you integrate the x. You integrate the x, and then you can get x squared over 2. So the finally is we have x squared ln x over 2, and then minus 1 over 4 times x squared plus constant. Okay, and in fact this is completely the same as this example. Okay, so and then you can take a look for some of the examples of your assignment, I mean your exercise, and then you can take a look to the question, so which is like the I. Okay, so you can turn to the question 8, the I. Okay, the question 8, the I. But there are the questions that using the integration by parts, and then you can try yourself. And the I means integrations of ln x, which I show to you here. Well, integrate ln x, which is in fact the same as just like here, 1 times ln x. Okay, we can't use substitution, and then we cannot integrate easily, but actually you can choose to use the integration by parts, which is u dv equals to uv minus integral v and then du. Okay, we need to choose one of it to be the u and the other one should be the dv. If it is a number and then also the ln x, so we can simply choose the u to be the ln x, because it is more difficult to be integrate, while dv we are choosing the 1. Okay, and then the next is that we are actually having to find du. Okay, d this one time, and then we got 1 over x. If you would like to find a v, so integrate this one for 1 time. If we integrate the 1, that means x, so v should be x. Okay, and then the next is you are going to do the substitution inside. U is ln x, v is x, so this one is v, and then this one is u. Okay, and then minus integral v. Integral v is x. So while du should be 1 over x times dx. Alright, so this 2x cancel out, and then that means x times ln x minus integral 1 times dx. And if we integrate the 1, that means we have 1 more x comes out, and the answers will be x ln x minus x, and then finally plus a constant. Okay, so that is how the I can be done. And with the two functions comparatively, natural log must be more difficult to be integrate, so we will choose the dv. So as I said, it should be easier to be integrate, so it should be like ex x and then ln x. Okay, so choose the dv whenever we have some exponential functions, and then the second we choose polynomial, and the last we will choose the ln x. Okay, so therefore choosing the dv, the easier to be integrate. This is the easiest. This is difficult to be integrate. Okay,